In this video, we will learn how to do a binomial expansion using the Pascal's triangle. But first, what exactly is a binomial and a binomial expansion? The word binomial is made up of two root words. Bi means two, nomial means terms. So a binomial is an expression that is made up of two different terms. And these are some examples. So now that you know what a binomial is, what then is a binomial expansion? To find out, let's take a closer look at the binomial of x plus 3 to the second and third power. We know the expansion of x plus 3 squared is x squared plus 6x plus 9, and the expansion of x plus 3 cubed is equivalent to multiplying x plus 3 squared by x plus 3, and this is just equals to x cubed plus 9x squared plus 27x plus 27. Well, expanding x plus 3 cubed was pretty tedious, right? Now imagine if you had to expand x plus 3 to higher powers of x. How can we do the expansion more efficiently? Well, let's first take a look at a more general case. Consider the expansion of x plus y at these different powers. We know the expansion of x plus y to the power of 0 is just 1, and x plus y to the power of 1 is just itself. Now, for the square of x plus y and the cube of x plus y, we already know that these are their expansions. Now we're ready to look out for some patterns. Firstly, what do you notice about the powers of x and y in the first and last terms of these expansions? Well, when the power is 1, the first term is x to the power of 1, and the last term is y to the power of 1. Similarly, when the power is 2, the first term is x squared and the last term is y squared. And the same thing happens when the power is 3. So we are actually able to obtain the first and last terms quite easily. Now how about these intermediate terms here? How do we obtain the powers of x and y? To find out, let's look at this quadratic expansion more closely. And for us to notice a pattern here, we're going to put y to the power of 0 here and x to the power of 0 here. And we know these terms are just equal to 1. So the two expressions are still equivalent. Now what can you say about the power of x in each of the terms? Well, the power of x decreases from 2 to 1 to 0, but the power of y increases from 0 to 1 to 2. You see that? There's also one more thing to notice. Look at the sum of the powers in each term. What do you see? The sum of the powers is always equal to 2, and this is equal to the power of the binomial. Now let's see if these observations are also true for the cube of x plus y. Again, let's rewrite this expression by putting y to the power of 0 here and x to the power of 0 here. And like just now, notice that the power of x decreases and the power of y increases. And the sum of the powers of each term is always equal to 3. And this is equal to the power of the binomial. So now, what do you think is the expansion of x plus y to the power of 4? Well, let's apply what we have just learned. The first term will be x to the power of 4 times y to the power of 0. The second term, the power of x will decrease to 3, and the power of y will increase to 1. And if we continue, we get x squared times y squared plus x times y cubed plus x to the power of 0 times y to the power of 4. And notice that the sum of the powers of each term is always 4. But we're not done just yet. do you realize that the coefficients of these terms are all missing? How do we obtain these coefficients? One way is to look at these binomial expansions over here again. And let's see if we can find any pattern in the way the coefficients occur. For the 0th power, the coefficient is just 1. For the first power, the coefficients are 1 and 1. For the second power, the coefficients are 1, 2, 1. And for the third power, the coefficients are 1, 3, 3, 1. Now let's find out how these coefficients are generated. Firstly, the edges are all 1s. Secondly, each row starts with a 1 and ends with a 1. You see that, right? Now, how about these intermediate coefficients? How are they generated? Suppose I do this. Does this help you see a relationship? Each term is actually obtained by adding the two terms just above it. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. The arrangement of these coefficients is what we call the Pascal's triangle. Now let's go back to the expansion of x plus y to the power of 4, and let's use the Pascal's triangle to obtain the coefficients. We know the first and last terms are 1 and 1 respectively, and the intermediate terms are just 4, 6, and 4. So all that is left now is to put these coefficients 1, 4, 6, 4, and 1 here, and this gives us the complete expansion of x plus y to the power of 4. So what have we learned so far? When we expand binomials such as x plus y to these powers here, the power of the first term, that is x, will decrease, and the power of the second term, that is y, will increase. And the Pascal's triangle help us to find the binomial coefficients easily. Got it?